Dear students, in the previous class we studied what is momentum and Newton's second law of motion. In today's class we will learn what is impulse and Newton's third law of motion. Now let us see what is impulse. Say, in order to fix a nail on the wall, we will apply a large force using a hammer so that this nail will penetrate into the wall. So using this hammer we will apply a large force within a short time. So this is called impulse force or impulsive force. So what is impulsive force? It is a very large force acting for a short time is called impulsive force. So impulsive force means a large force acting for a very short time is called impulsive force, or we can say impulse as the product of force and time. So the product of force and time is impulse. So impulsive force means it is a very large force acting for a short time is called impulsive force, while impulse is the product of force and time. So impulse is equal to force into time. Then what is the unit of this impulse? Yes, impulse means force into time. Then the unit of impulse is unit of force into unit of time. So what is the unit of force? Unit of force is Newton. Unit of time is second. So the unit of impulse is Newton second. So what is the unit of impulse? Newton second is the unit of impulse. Impulsive force is a very large force acting a very short time is called impulsive force, and impulse of force is the product of the force and the time. So impulse is equal to force into time. What is its unit? Newton second is the unit. In the previous class, we studied the mathematical representation of Newton's second law of motion as F is equal to m into v minus u by t. Then impulse is equal to F into t. So instead of this F, we have to substitute m into v minus u by t. So that the equation becomes impulse is equal to m into v minus u by t into this time t. Okay, so here 1t is in the denominator and 1t is in the numerator. So we can cancel these two t. So that the remaining terms are m into v minus u. So what is m into v minus u? Yes, that is mv minus mu. mv minus mu. So what is mv? Mass into final velocity. Mass into final velocity means final momentum minus initial momentum. Final momentum minus initial momentum. It is known as change in momentum. So impulse is equal to change in momentum. So using second law of motion, we can say impulse is equal to change in momentum. See, let us take the previous example. This hammer have momentum. When this hammer strikes this nail, what happens? This momentum of this hammer becomes 0, so that this nail penetrates into the wall. That means within a short period of time, the momentum of this hammer changes. The hammer takes a short time to change its momentum. So that is called impulse. So change in momentum is equal to impulse. So every object which is having mass and velocity will have what? Momentum. So this hammer have momentum. When this hammer strikes this nail, it will have momentum. But after the striking, what happens? Its momentum gets reduced to 0. So there is a change in momentum, and that change in momentum is equal to impulse. So mv minus mu is change in momentum. This is known as impulse momentum principle. So this is called impulse momentum principle. So mv minus mu, that is change in momentum, is equal to impulse. Hence it is called impulse momentum principle. So it states that a change in momentum of an object is equal to the impulse experienced by it. So what is impulse momentum principle? It states that a change in momentum of an object is equal to impulse experienced by it. So change in momentum of an object is equal to impulse experienced by it. So change in momentum is equal to impulse. So we can conclude impulse is defined as a change in momentum of an object. So impulse is defined as a change in momentum of an object. Ft is equal to mv minus mu. So this is called change in momentum. How will be the ratio between the force and time when same change in momentum occurs? In such cases, change of momentum is constant. Say, we studied impulse is equal to change in momentum. And what is impulse? Impulse is equal to force into time. That is, force into time is equal to change of momentum. See, if we consider this change of momentum as a constant, then F into T is equal to constant. If we bring this time T to this side, then what happens? F is equal to a constant into 1 by T. From this we can write F is inversely proportional to T, or F is directly proportional to 1 by T, or F is inversely proportional to T. That means whenever this time increases, this force decreases. If T increases, then force decreases. So that is inversely related. If one increases, then another decreases. So whenever this change of momentum is constant, the force acting on the body will be inversely proportional to the time taken. So whenever this change of momentum is kept as constant, then the force acting on the body will be inversely proportional to the time taken. So F is inversely proportional to T, or F is directly proportional to 1 by T. Explain the following situations by relating the force and time. So by using this relation, we have to explain this situation. So from this, what we can understand, whenever the time increases, the force decreases. So if time T increases, then force increases. If T increases, then F decreases. That is inversely proportional. The first question, at the time of catching a cricket ball, the time of catching is extended by moving the hand backward with the ball. So what is the reason? So during the catching of cricket ball, catching is extended by moving the hand backwards. By doing this, what happens? The impact on the hand decreases. But based on force and time, how can we relate this? So by doing this, what happens? The time taken to stop the ball increases. So when the time taken to stop the ball increases, then force acting on the hand decreases. So using that relation, we can say whenever this time T increases, the force acting on the hand, or the impulse on the hand, decreases. Due to more time taken to stop the ball, the rate of change of momentum of ball is decreased, and hence a small force is exerted on the hands of the player. so the hands of the player do not get hurt. So this is the reason. Second question. During a pole vault jump, the impact is reduced by falling on a foam bed. Why? So what is the reason? Why these foam beds are used in pole vault jump? Yes, it is because since he has mass and he has velocity, he has momentum. So when he falls on this bed, suppose imagine that this is a hard bed. So when he falls on this bed, suddenly his final velocity becomes 0. So initially he has momentum and finally his momentum becomes 0. That means the time taken for change of momentum is less. If the time taken for change of momentum is less, then what? Impulse will be more. So in order to increase the time we are using, they were using this foam bed. So on falling on this foam bed, suddenly his final velocity does not becomes 0. After some times only this final velocity becomes 0. So that is the reason. So this foam bed helps to increase the time of the athlete's fall to stop after making the jump. This decreases the rate of change of momentum and hence the force. As a result, athletes does not injured. Hay or sponges are used while packing glasswares. Why? So why this hay or sponges were used while packing the glasswares? It is because the sponges or hay increases the time of experiencing the jerk during transportation and collision. This helps to avoid the breaking of glass due to collision. So whenever this time increases, then force acting on the object decreases. Karate expert move their hands with great speed to chop strong bricks. Why? So why? What is the reason? It is because when karate expert moves his hand with great speed, the rate of change of momentum or impulse on the brick increases, hence the brick breaks. So if we apply a large force within a short time, then the impulse will be more. So when the impulse is more, this brick breaks. Let us see some examples for impulsive force. Falling down the glass to the floor, hitting a nail using hammer, kicking a football, then collision of cars, striking a tennis ball, etc. So all these are some of the examples for impulsive force. So in all these examples, we are applying a large force within a short period of time. So that is called impulsive force. So while kicking a football, what we will do? We will apply a large force within a short period of time. Then during the collision of cars also. Then striking a tennis ball. So in all these cases, we apply a large force within a short period of time. Hence it is called impulsive force. So in today's class, what we learnt? Yes, the first part we learnt is what is impulse. So what is impulsive force? So impulse is the product of force and time, while impulsive force is a force, large force exerting on a short time is called impulsive force. And this impulse is equal to change of momentum, or impulse is equal to change in momentum.